I think a lot of the conversations generated excitement, enthusiasm about this center as a intellectual hub of the campus. So get rid of our old ideas about what our library looked like when we were 6 or 8 or 20 or 40. We're starting to think about what it can look like as something more than a repository for books or a place to study. So this idea of a center or intellectual hub is intended to draw faculty and staff and students, members of the community, alumni to the campus to do some of the things you would expect, study and reflect, but also to engage in the intellectual life of the campus.
Here we are looking at a student and faculty-centric facility with the library, where we know everyone on campus essentially has 4.8 devices and everyone wants to come in and use them and plug them in. That's a huge plug load, which you'll hear about in just a little bit. So we have to understand that there's a demand on this facility in terms of using laptops and technology, and that means servers, and we have a pretty big energy load that everyone is going to expect in the facility. The other thing is, due to the block plan and the way Colorado College works, there are extended hours that are needed in this facility in terms of being there late into the night, the 24/7 capabilities of the building. It doesn't shut down and can then basically go dark.
First phase of the plan is energy conservation and efficiency. The second phase is increased use of renewable energy. The third phase is combined heat and power. The idea of combined heat and power is that we can't get all of the energy we need from renewable sources, so any additional energy we need on campus, we want to make sure that we're getting the cleanest energy possible and we're using it as efficiently as possible. And the fourth phase is carbon offsets, and basically what that is it's working with the community to provide additional carbon offsets.
The biggest bang for our buck is simply going to be to reduce how much we're using, okay, aka conservation, right? Now that primarily comes down to lifestyle changes and smart building design. Once we've got those sorts of things in place, the next level of emissions reduction, the next biggest bang for our buck, is to focus on efficiency, okay? Where we can't simply change the way that the building and its people are using energy, we start to engineer in energy savings, okay? This includes all of the sorts of state-of-the-art building design pieces that you might think of. We'll get into some of those topics a little bit more in depth later on. Once we've reduced as much as we can and we've got the most efficient systems in place that we can possibly have, then our next focus should be on renewable energy. Tutt Library currently uses about 6% of our campus energy, so making this a net neutral building is going to have a visible impact on our overall campus energy use, our overall campus carbon footprint, and all the emissions that go into that as well. The project design goal is to be net zero energy, net zero carbon. The plan is to put in a system that's called cogeneration or combined heat and power. Okay, those are some synonymous terms for the purposes of this project. Remember those terms, they're a key part of this plan. Essentially what's happening is we're putting in a large generator in the new library, okay, and it's just like any other generator that you may be familiar with. It creates electricity, it generates electricity on its own, okay. This one's big though. It's designed to produce 100% of the power that we're going to be using in the new library project. Okay, so that's important. We're going to be 100% self-sufficient in creating our own electricity for this project. And we have solar panels going on the roof of the new library as well. And given that we're already producing 100% of the electricity that we need with this combined heat and power system, all the clean renewable energy goes where? Out to the grid, which means we're offsetting coal energy and all of its carbon emissions, which gives us quantifiable carbon credits that we can use to offset the emissions coming from the natural gas. So we've got a building that produces 100% of the electricity it needs on an annual basis, 100% of the heat it needs on an annual basis, and it does it with net zero carbon emissions.